Okay, in the previous video we was discussed about formal language, basic blocks of languages, symbols, alphabets, okay, and many properties of sigma. Now in this lecture I will describing the formal automata or formal representation. Basically, let us say a language L1. Okay, L1 is the set of strings. Okay, let's say sigma is A and B. Set of strings where the set of strings where the strings starting with A, alphabet A. It is nothing but infinite. You can go through it. A, B, in this way. Now, my question is that suppose one of my friend made a string such a manner A, B, A in this way. Is it present in this or not? Yeah. From the point of view, you can say that it is present. But in case of computer, he can't see anything. So, or any machine, he can't see anything. So, it is very difficult for that machine to produce it. So, we have to approach is that trial and error method. Just check it this, check it this, check it this, check it this. This is basically in a machine is done. What? Let's say a language L. Its finite representation, let's say F. This is nothing but the finite representation of any language. Okay. I am giving us string S. If it is present, then Y. If it is not present, then N. Fine. You can also take in this way. From 2 output is coming. If it is present, is Y, or if it is not present, is N. Basically, the basic diagram is like this way. Okay, not in this way. Why? Because if it is yes, then there is some what I will say, some digital part of electronics can use. Okay, forget about things. This is the formal representation. Formal representation. If the string is belongs in this cell, then yes. If this is not belonging, then now this is nothing but the formal representation. So the formal representation can be given in such a way. Okay, I'm just the formal representation. Let's take another example in this way. The formal representation. I'm giving everything about the circles, etc., etc. Please be patient. Okay, fine. This is okay. So this is our finite representation. Okay, FR. I'm making very shortly finite representation. What is this circles? These are nothing but states. What are these circles? States. There is 3 states, A, B and C. You can see that a circle having 2 circles in this case instead B. This is our ending state. B is our ending state. Now question is, what is the basic state or starting state? This is starting state. You can see that from somewhere this something is coming. So A is our starting state. Fine. Okay. Let's check this is belongs here or not. Where? Okay. The L1 is nothing but the set of all strings having the first element as A. Got my point? L1 is my language having the all strings having the first A, first letter as A, or first symbol as A. So you can easily say that this belongs to this. Now you have to prove this in the machine way or machine typed way. So from I have come here A. From A I have to go which words? You can see that towards B. Is it? Yes. To get the A. I am repeating again. From basically I am at the initial point, that is A. Now I have to get A. Forget about these things. I have to get only A. In which path I will get A? On this path. And this is going towards B. This is nothing, okay? And this is going towards B. So from A I have to go B. I am now in this point. Right? From this point I have to go this. You can see that here is a self loop. Yeah. So with self loop I can go A or B both. So to go B I can choose this path also. Yeah. Fine. Let's take another. Okay. From B we have to go again A. So you can see that I am starting from an initial state and ending the final state. So this string is belong my language. Okay. Let's take another example to understand it. BAB. I told that L1 is the language of strings where the first symbol of string is A. So you can easily say that. Hey, this is nothing. This doesn't belong to L1, sorry. So you can, from this you can conclude that BAB is not in L1. But you have to prove this in such a way. At first state I am at initial point A. From A to B I have to go which words? These words. Fine. C. From C I am now at this point. From A again B. So you can see that I am started from the initial point A, but my ending point is B, not C. So this doesn't belongs to L1. This is nothing but the formal representation or formal automata. This is an example of DFA. We will discuss about later in the next video. Thank you.